All right, we're going to talk about the kinetic energy. What is kinetic energy? It is a kind of energy that is posed by a body by virtue of its motion. So basically, a body is in the motion, we can say it is having kinetic energy. So suppose there's a different kind of motion you can see over here. The one is the vibrational motion. So whenever a body is having a vibrational motion, it contains the vibrational kinetic energy. Whenever you can see in this picture, basically when a body is in a kind of rotational motion. So a body when it is in the rotational motion, we can say it has the rotational kinetic energy. And here in this case, suppose this man is moving forward with a certain velocity. So this is what we call linear kinetic energy or translational kinetic energy. The value or the mathematical expression of the kinetic energy is product of mass, half of the mass, and the square of the velocity of the body. So if this man is moving with the velocity v and the mass of this man, suppose m, so the kinetic energy of this man will be half mv square. Now we have to find out this from where this half mv square is coming. We have to drive out by applying a proper concept. Now you can see this boy is kicking the ball. Suppose the ball was at rest. So the initial velocity will be 0. Now he kicked the ball. So he kicked the ball, that means he applied certain force for a small instant of time. And the ball started moving in a straight line. So let's take this is the straight line where the ball travels. The ball traveled from this position A to suppose this position B. And here the velocity of the ball will be, final velocity will be, suppose V. Now when he is applying the force, obviously he will apply the acceleration because force is mass into acceleration, and acceleration actually increase the velocity. Now you can see it was 0 over here. Now the velocity V, it may have the certain value but not equals to 0. So suppose this ball acquired the velocity of V and traveled a distance of s. Now we know from the previous video you might have seen where the work is actually energy. So we will keep this in the mind. Its energy is nothing but a capacity to do work. Okay, now we have to find the expression for the work. Okay, so work is, we know, force into displacement. Okay, now you see displacement and cos theta. So you can see the force applied, this man applied the force in this direction and the displacement also in the same direction. That means it is a parallel case. So theta will be over here 0 degree. So we can write work is nothing but force and displacement. So we'll keep this equation in our mind. We're going to put the value later. Okay. Now we know the linear motion equation is v square, this is the final velocity, is equals to u square plus 2as. Now suppose the distance traveled from here to here s, so we can write v square minus u square upon 2a, and this will be the value of s. So we'll give the equation, this is the equation number 2. Okay, and we know force is equals to mass into acceleration. This is the equation number 3. Now we will put the value of equation number 3 and equation number 2 in the equation number 1. So when we are putting the value of equation number 3 and 2, we can write work is mass into acceleration. Instead of force, we are putting this value. Okay, and then the value of s, I'll write v square minus u square upon 2a. Now we can cut down this a. So work done will be half. This half will come over here, mass. And you can see the v square minus u square. But we know here u is actually 0. So we're going to put the 0 over here. And the work done will come half mv square. Okay. Now you can see over here, this ball right now is having what kind of work this man has done to make the ball move with the velocity v. So it will acquire the velocity v. So that means the work done in order to create a kind of kinetic energy is half mv square. Now this equation, we can give the equation A. Okay, now you see that we have already said that the work is nothing but, or energy is nothing but a capacity to do the work. So we can write, instead of writing work, we can write kinetic, kinetic energy, which is equals to work, will be half mv square. So ultimately we can say kinetic energy, which is K, will be half mv square. And that is the expression for the kinetic energy. Hope you understood this. Thank you so much, and if you like this video, share with your friends and do subscribe my channel. Thank you so much.